వాయిస్ ఓకేనండి? హలో, పవర్ కట్ అయింది, మళ్ళీ వచ్చిందండి. ఓకే, సారీ ఫర్ ది డిస్టర్బెన్స్. Okay, so second formula is the, so consider the curve in terms of y, that means x is equal to function of y. Now assume s denotes the length of the curve, so length of the arc of the curve between the 2 points. So I am taking the 2 points, y is equal to c to d, and the length of the arc is, length of the curve is c to d under root of dx by dy whole square plus 1 into dy, or you can write integral c to d under root of g dash of y, plus 1 into dy. Geometrical view is, I am taking the same curve. So this is the curve, and this curve we can write y is equal to function of x, or we can write x is equal to function of y also we can write. Two ways we can write. Now in this one we will take the lowest and highest value of y. Now y is equal to c to d. So this is the result. So anyway, the finding the length of the curve, we have the two options. We can write in terms of total x, or we can write in terms of total y. Okay, so this is the first way. And one more way we can easily find the length of the arc. Here assume, here I am assuming s be the length of s of the arc of the curve between the points corresponding to,
స్క్రీన్ రావట్లేదు సార్.
రావట్లేదా? మరి చెప్పట్లేదు. ఇప్పుడు ఓకేనా అండి? ఓ కృష్ణ. ఓకే, నౌ స్క్రీన్ ప్రజెంట్ అవుతుందా అండి? కొంచెం మీరు రెస్పాన్స్ ఇస్తే నాకు అర్థమవుతుందా అండి, స్క్రీన్ కనిపిస్తుందా కనిపించట్లేదా, ఓకే, అర్థమవుతుందా లేదా అని. ఓకే, సైలెంట్ కూర్చుంటే అది ఇంటర్నెట్ పోయిందా అర్థమవ్వదు, మీకు స్క్రీన్ ప్రజెంట్ అవుతుందా అర్థమవ్వదు. ఓకే, నేను వరుస చెప్పుకుంటూ వెళ్తూనే ఉంటాను. ఓకే, సో ఎనీవే, ఓకే, లీవ్ ఇట్. నౌ ద లెంత్ s of the curve of between the points, I am taking the t1 and t2, t1 and t2. So here the t is independent variable. I am taking here the x is the function of t and y is the function of t. Y is the function of t. I am taking the points of t is equal to t1 and t is equal to t2, and t1 is less than t2. Then the length of the curve is, so length of the curve is s is equal integral t is equal to t1 to t2 under root of dx by dt, because it is the parametric form, and dy by dt into dt. Okay, so this is the second way for finding the length of the curve, and the curves are given in parametric form. So curves are given in the parametric form. So here the x is equal to function of t and y is equal to function of t. So this is the second one, and we have one more. This is the parametric form. Next one, we have the second one is the same third and fourth. So that is the polar form. I think we have seen in the previous classes polar form. So curves are given in polar form. Polar form. So here consider the curve is, consider a polar form, polar curve. R is equal to function of theta. So now then the length of the curve is, so length of arc of the curve between the points corresponding to suppose limits are theta 1 to theta 2, theta 1 to theta 2, and theta 1 is always less than theta 2. Then the formula is integral t1 to t2 under root of r square plus dr by d theta whole square into d theta. So this is the third formula for finding the length of the curve. Again here we have to write in another form. Same, I am taking here the curve is theta is equal to function of r, and I am taking the limits are t r is equal to r1 to r2. Then our length of the curve is s is equal integral r is equal to r1 to r2 under root of 1 plus r square d theta by dr whole square into dr. So this is the second way in polar form. So finally in the Cartesian form we have the only two forms. In the parametric form we have the one form. In the polar form we have the two forms. Okay, so anyway we will see one problem in this both parametric form and the Cartesian form. Definitely we will get the idea. Now here I am giving a curve like this. So assume this is the y-axis and this is the x-axis. I am taking the unit circle. X square plus y square is equal to 1. X square plus y square is equal to 1. Now the geometrical assume it is the 1, and this is the minus 1, this is the plus 1, and this is the minus 1, and this is our unit circle. This is the unit circle. So this is the unit circle. This is the So this is the unit circle. Now what is the total length of the curve? So length of the curve means it is nothing but perimeter. What is the perimeter of the circle? Radius is 1. Perimeter
2 pi.
2 pi, very good. So 2 pi r, but here the r value is 1. So 2 pi is the perimeter. Now I want to calculate the arc length, this arc length. So the total is 2 pi. So it is the pi by 2, this one also pi by 2, and this is the pi by 2, and this one also pi by 2. Now I want to find the arc length in between x value is 0 to 1 only. So 0 to 1. What is the function here? Our function here x square plus y square is equal to 1, and we know the arc length is pi by 2. Anyway we will see the calculation by using integrations. Okay, now here the length of the curve. So length of the arc. We have the two formulas, integral a to b under root of 1 plus dy by dx whole square into dx. What is the a value? 0 and b value is 1. Integral 1 plus. Now here what is the x square plus y square is equal to 1. After separating the y, now y is equal to under root of 1 minus x square. After differentiating with respect to x, what is the result? 1 by 2, 1 minus x square power minus 1 by 2 minus 2x. That means dy by dx here will get the minus x by under root of 1 minus x square. That means after taking the whole square we will get the x square by 1 minus x square into dx. That means integral 0 to 1. After rewriting we will get the 1 by under root of 1 minus x square only, because x square will cancel. So 1 by under root of 1 minus x square into dx. Now what is the integration of 1 by under root of 1 minus x square? Anybody? It is the sine inverse of x only. So limits 0 to 1 and upper limit is 1. So sine inverse of 1 minus lower limit is 0. So sine inverse of 0, it is the result is pi by 2. But anyway we know the answer. So this is the in the Cartesian form. But same problem. So it is the first approach. First approach for finding the length of the arc. Similarly second one. So second one, just I am copying this total. Just a minute. Okay, now so here same formula I can write, suppose okay. Now same. So assume this is the y-axis, this is the x-axis, and we know the given curve is the unit circle, and we want to find the arc length. This arc length. So we know the answer, it is the pi by 2, and the previously just we have calculated in terms of x. Now here we will see the in terms of y. What is the formula for finding the arc length? The length of the arc or length of the curve. So length of the arc is integral c to d under root of 1 plus dx by dy whole square into dy. What is here our given curve? X square plus y square is equal to 1. After separating the x, now x is equal under root of 1 minus y square. After differentiating with respect to y, definitely you will get the minus y by under root of 1 minus y square like the previous. Now here, so and the y limits. So y limits are, it is 0 and 1. So integral 0 to 1 under root of 1 plus y square by 1 minus y square into dy. That means integral 0 to 1 after rewriting 1 by under root of 1 minus y square into dy. Now the integration of this one is sine inverse of y limits 0 to 1. That means sine inverse 1 minus sine inverse 0. So we know that answer pi by 2. Okay. So this is the second way. So this first and second, it is in terms of only Cartesian form. Next one we will see in the parametric form. So the parametric form method, third one, we will take the parametric form. Parametric form. So anyway it is the y-axis, this is the x-axis, and our given curve is unit circle. So minus 1 plus 1, and it is the plus 1 minus 1. So this is the our unit circle. Equation of the circle is x square plus y square is equal to 1. and this length we have to find. The length is pi by 2, we know that. Length is pi by 2, we know that. This total. And just convert into parametric. So what is the parametric form of x square plus y square is equal to 1? X is equal to cos t and y is equal to sin t and t is in between. So t is in between 0 to pi by 2. Okay, now how can find the length of the arc? So length of arc is integral t2 t1 to t2 under root of dx by dt whole square plus dy by dt whole square into dt. What is the t1 and t2? So 0 to pi by 2 under root of dx by dt, that means minus sine, that means just differentiate. After differentiating, dx by dt is equal, here we will get the minus sine t only, and dy by dt, here we will get the cos t. Just substitute all in this integration formula. So sin t whole square plus cos t whole square into dt. That means integral 0 to pi by 2 under root of this is 1 and dt, and integration of 1 is t, limits from 0 to pi by 2. So it is finally pi by 2 minus 0. So the length of the arc is pi by 2. So like that you can easily find the length of the arc. Okay, so 3 ways. Similarly, we can easily find this length of the arc in the 2 more forms. That means in the parametric form, that is try. Okay, now this is the idea of the finding the length of the arc in parametric form. Now here just observe here the formula. Suppose here x is equal x of t and y is equal y of t, and the length of the arc. So length of the arc is integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square into dt. So it is in 2D structure, length of the arc. So length of the arc. Now this one I am extended to the in the 3. So this is the parametric form. Parametric form. So parametric representation or parametric form of curve. Next one, similarly I am extend to the parametric form in the 3D. So x is equal function of t and y is equal function of t and z is equal function of t. Now how can you find the length of the arc? Is integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square plus anybody dz by dt whole square into dt. Now this is the length of the arc. Okay, and here the x is equal x of t and y is equal y of t and z is equal z of t. It is the parametric form of the curve. So parametric form of the curve. Okay, so now we will solve the problem. So line integral with respect to the arc length. Now this one gives the arc length or length of the arc in 2D, and this is in 3D. Similarly we can extend to the 4D and 5D and ND. Okay, now come to the first problem in this line integral. I think we have seen the few problems in previous class. Now we will see few more problems in now. Suppose here I am assuming Now I am assuming, suppose let assume C be a simple curve, and let assume the parametric form is of C be written as x is equal function of t and y is equal function of t and z is equal function of t, and these t values are in between a to b, and here I am assuming the position vector is r, position vector of a point on the curve so it is in the form of r is equal x of t I plus y of t j plus z of t k, and here the t values are in between a to b. So this is the position of the vector. Okay, now here I will write the, so here so this is our curve, this is the curve C in 3D. X is equal function of t and y is equal function of t and z is equal function of t, and so this is the our curve. Here I am taking continuous function on the curve. So let us assume f of x comma y comma z be a continuous function on the curve C. So then the line integral of f over the C with respect to the arc length is integral f of x y z into ds. Here what is the ds here? What is the ds? Arc length, very good. So ds is the arc length. ఒక నిమిషం అండి. So ds is the arc length. That means in terms of three symbols, how can we write? So we can write in the parametric form. So integral a to b, f is function of t, that means function of x, and that is the function of t, and y is function of t, and z is function of t, and ds is equal, what is the ds here? Ds is equal under root of dx by dt whole square plus dy by dt whole square plus dz by dt whole square into dt. So here we can write ds in place of ds under root of x dash, simply I am writing x dash whole square plus y dash whole square plus z dash whole square into dt. Okay, now this one is the line integral with respect to arc length. arc length. Okay, now finding the line integral. So by using the arc length is, so integral a to b f of x comma y comma z under root of x dash square plus y dash square plus z dash square into dt. Now we will see the few problems in this line integral with respect to the arc length. The first one is, so evaluate the line integral. I think in the previous class also we have seen few problems in the line integral. Now evaluate the line integral x y square into ds, where c is curve, so defined by x is equal 3 cos t and y is equal to 3 sin t, and I am taking t is in between 0 to pi by 2. Now pi by 2. So now geometrically what is our curve? So this is the y axis, this is the x axis. Zero, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now, so this one is the parametric form of the equation of the circle. X is equal to 3 cos t and y is equal to 3 sin t. Center 0, 0 and radius is 1. So radius is 3. That means this is the our circle. So this one is x square plus y square, x square plus y square is equal to 9. But it is clearly given, it is in the parametric form. And we have to find this length of the arc 0 to pi by 2. So 0 to pi by 2 means we have to find this arc length. Okay, and we have the three formulas. You can apply any one of the formula. So what is our formula? Integral a to b f of x y z into ds. What is the formula? Integral t1 to t2 f of x y z into under root of x dash square plus y dash square plus z dash square into dt. Now substitute all. What is our f here? F is equal to xy square and x is equal to 3 cos t, y is equal to 3 sin t, and t1 is equal to 0 and t2 is equal to pi by 2. Substitute all. F in terms of the parametric form, f is equal to here 3, x means here the 3 cos t and y is the 3 sin t whole square. That means our, what is our f? It is the 3 cube into sin square into cos t. And come to the here dx by dt. What is the dx by dt here? Minus 3 sin t only. And the dy by dt is 3 cos t. Now substitute all in the given formula. So here we will get the integral 0 to pi by 2. What is the function f? Function f is the 3 power 3 sin square t into cos t and the under root of. So here we have the only in terms of the 2. So here z is, there is no z. Now under root of x dash square. That means minus 3 sin t whole square plus 3 cos t whole square into dt. That means integral 0 to pi by 2 3 power 3 sin square t into cos square t. What is under root of? minus 3 sin square t plus 3 cos square t is, what is the result? Try cheyandi. It is the only 3 dt. That means 3 power 4 integral 0 to pi by 2 and sin square t into cos t into dt will get. Now after simplification, now here we have the it is f power n into d. So f power n into f dash dx, directly we have the formula according to substitution method, f power n plus 1 by n plus 1. Now this one is a 3 power 4. Now by use substitution method we can solve. Now here we will get the sin power 3 by 3 and limits from 0 to pi by 2. Upper limit is pi by 2, so 3 power 4 by 3 sin power 3 pi by 2 minus sin 0. So finally here we will get the 3 power 4 by 3. So here we will get the answer 3 power 3, that is the 27 is the result. Okay. So like that you have to find the line integral with respect to the arc length. So this is the first problem. So similarly we will find the second problem in this one. So this is the finding the arc length. So line integral with respect to the arc length. Now we will see the one more problem in this line integral with respect to the arc length. So second problem, second one. So evaluate the arc. So evaluate line integral x square plus xz into ds, where C is the curve defined by x is equal to 4y and z is equal to 3. From the point 2 comma 1 by 2 comma 3 to the 4 comma 1 comma 3. So this is the curve, and here it is given the points. Now anyway, so we need here either parametric form. So for Cartesian form we cannot calculate. Now here I am taking the parametric form. So parametric form here I am taking. So here x is equal to 4y. So x is equal to 4y means I am assuming here x is equal to t. After taking x is equal to t, what is the y value? Our y value is 1 by 4 into t, and z is equal to 3, directly given z is equal to 3. And here now what is our t limits? Already we are taking here the t, x is equal to t. Now x values are, what is the x values here? So x values are 2 and 3, so 2 and 4. So now x values are in between 2 to 4. So x values are in between 2 to 4. So t values are also in between 2 to 4. Okay. That means now we have the parametric form. So x is equal to t and y is equal to 1 by 4 into t, z is equal to 3. Just you have to find the ds. What is the ds here? Under root of x dash square plus y dash square plus z dash square into dt. Just differentiate. After differentiating, what we will get here? It is the 1 square plus 1 by 4 whole square plus 1. So it is the 0 square, because after differentiating it is the 0. So dt. Now finally here we will get the root of 17 by 4 is the ds. So root of 17 by 4 is the ds. Now come to the question. What is our question? Our question is integral, line integral. So x square plus xz into ds. Now substitute all the values. T value we have the 2 to 4, and x is, what is our assumption? T square, and t, z is we are assuming the 3 into ds is root 17 by 4 into dt. So here dt is missing. Now just calculate, we will get the line integral now. So integral 2 to 4 and so root of, direct solve it down. So root of 17 by 4. So root of 17 by 4, integration of t square is t cube by 3 plus integration of t is t square by 2, limits from 2 to 4. 2 to 4. Now under root of 17 by 4, upper limit is 4. Upper limit is 4. So 4 cube by 3 minus 3 by 2 into 4 square for upper limit, and for lower limit 2 is the lower limit, 2 cube by 3 plus 3 by 2 into 2 square. Now root 17 by 4 after simplification. Okay, first term, this is the first and this is the third term. So after joining these two, so 1 by 3 you can separate. So 1 by 3 of 4 cube minus 2 cube, and after separating the 3 by 2 here, 4 square minus 2 square. That means root 17 by 4 into, so 1 by 3 it is 64 minus 8. So 64 minus 8 is the 56 plus 3 by 2 into, and 16 minus 4 it is the 12. That means it is the 3 into 6, 56 by 3. That means 18. So 56 by 3 into root 17 by 4, root 17 by 4. Finally after rewriting we will get the here 55 root 17 by 4 is the result. So this is the line integral. Okay, but here I have ఒక నిమిషం అండి. Just a minute. So here finally here we will get the 55 into, so 55 into root 17 by 4. It is the first result. Now same problem we will solve in the another way also. How? Here, now here I am taking, the previously I am taking t is equal to x is equal to t. Now here I am taking small change. If I am taking suppose y is equal to t, then what will happen? X is equal, will get the 4t, and z is as it is, nothing new. And now the limits are, what are the limits? Now here I am taking x, y is equal to t, so that means y values are in between 1 by 2 to 1. That means we will take our t limits 1 by 2 to 1 only. In the previously we are focusing on the x is equal, we are taking t. That's why we are taking the t limit 2 to 4. Here we are focusing on y. Y is equal to t. That means we will take the limits. T limits are 1 by 2 to 1. So same. First of all, you have to find the ds is equal under root of x dash square plus y dash square plus z dash square into dt. After differentiating x, here we get the 4 whole square. After differentiating with respect y, so y, here we get the 1 and z 0 dt. That means it is the root of 17 dt. Now come to the calculation part. Now the line integral c x square plus x z into ds. Now substitute. T limits are 1 by 2 to 1 and the t. So x is equal to 4t, that means 4t whole square, and x 4t and z is 3 into ds. ds is root 70 into dt. Now simplify. So integral 1 by 2 to 1 and t square. So 4t square is a 16t square plus 12t into root 17 dt. After integrating, so root 17, 16 into t cube by 3 plus 12 into t square by 2, limits 1 by 2 to 1. So root 17. Now anyway, so here I'm now we'll simplify. Okay. So upper limit is 1. So 16 by 3 plus 12 by 2. Lower limit is 1 by 2. So 16 by 3, 1 by 2 whole cube plus 12 by 2 into 1 by 2 whole square. That means here root 17. So definitely here we'll get the after simplification. Anyway, so I am giving this calculation part to you just to calculate. Now definitely we'll get the result is 55 into root 17 by 4 only. Finally the conclusion, you can focus on the x or you can focus on the y, that is your wish. Or from these points also, from these points, what is the points here? What are the points given here? Points are here 2, 1 by 2, 3 and 4, 1, 3. Suppose here I am taking, so this is for homework for you. It is the third approach. Third approach is, now the given points, what are the given points? 2, 1 by 2 and 3 and 4, 1. In this one, just write the parametric form. So the parametric form is x minus x1 by x2 minus x1 and y minus y1 by y2 minus y1, and okay, so from this one also you can get, but you can try this one also. So this is the third method, but 2 methods enough for this problem. Okay, so finally you can choose x is equal to t or y is equal to t. If x is equal to t, our limits are 2 to 4. If y is equal to t, our limits are 1 by 2 to 1. Okay, so this is the 2 problems. Now anyway here I am giving homework problems to you. Now try to practice the problems. Okay, 2 problems I am giving in this one. The first one is homework 1. I will give the results also. The first one is evaluate line integral x square y into ds, where C is the curve defined by x is equal to 2 cos t and y is equal to 2 sin t, and the t limits are 0 to pi by 2, and the result is 16 by 3. This is the result. Now try to solve, same as the previous one, nothing new. Now the second problem is evaluate line integral x square plus y plus z square into ds, where the curve is C is the curve defined by 2x is equal to y is equal to z, and directly sometimes they will give the like this, x is in between 0 to 4, or sometimes they will give the points like this from the point r, from the points 2 comma 4 comma 4 to 4 comma 8 comma 8. In this case you can fix any one of the symbol. If you can fix the suppose x symbol, we will get the t variable is the 2 to 4. If suppose you can fix the y is equal to t, then we will get the 4 to 8. Okay, that is your choice. Now here the result is, so 316 is the answer. So here the answer 16 by 2. So 16 by 2 is the answer. Okay, so this is the first type. Next one, we'll discuss one more, line integral of the vector fields. That is the second one. This is the line integral of, so line integral with respect to the arc length or length of the arc. Now the next one is the, I am assuming here the f is the vector field. Now f is equal, f is function of x, y, z, it is equal f1 function of x, y, z, and f2 function of x, y, z, and f3 also function of x, y, z, and I am assuming this is the a vector field that must be the continuous function on C. What is our C? Now we are assuming the C be a simple curve, and the x is equal x of t, y is equal to y of t, and z is equal to z of t is the parametric form of curve, and from A to B. So then the line integral is, I think we have seen in the previous class few problems. So line integral of f over the given curve C is defined by integral f dot dr. What is here dr? Our r is the position vector. Already we know that. Now r is function of t, x is equal to x of t plus y of t, j plus z of t, k. So here the dr means dr by dt is equal to dx by dt I plus dy by, so dy by dt j plus dz by dt k. It is the dr result. Okay, now after rewriting, now integral, now what is our f? F is nothing but f1i plus f2j plus f3k into dr. What is the dr here? dr is x dash t x dash t plus I and y dash t j z dash k, or we can write like this also after rewriting. So f is equal to f1i plus f2j plus f3k. This one we can take integral f1 dx plus f2 dy plus f3 dz. You can write like this also. Now after expanding, what will give the result here? Integral on c. So here c means here integral a to b, because we are taking the parametric form of this curve. C is x is equal to function of t and y is equal to function of t and z is equal to function of t, parametric form, and t is in between a to b. Then the integral a to b f1 is function of t only into dx by dt into dt. That means here also dr is equal, we will write the dx by dt I plus dy by dt j plus dz by dt k into dt. Okay, now this is the first one, and plus second one is integral a to b f2 like this same, f2 into dy by dt into dt. Now third one is integral a to b f3 into dz by dt into dt, after substituting this whole part. Now this one is the line integral of a vector field. Now we will see the two problems in this. After that I will give the homework problem. Okay, now the second one is the line integral of vector field. Line integral of vector field. Now we will see the one problem. Now the first problem here, not one problem, we will see the two problems. So evaluate the line integral of our vector is 3x square plus 6yi minus 14yz j plus 20xz square into k, and from the points 0 0 0 2 1 1 1 1 1 along the curve is, along the path curve is x is equal to t directly given, and y is equal to also t square, and z is equal to t cube. Just you have to find the line integral. So this is very simple, because already it is clearly given. X is given, and y is given, and z also given, and the limits. Now very simple here, 0 0 0 2 1 1 1, that means our t limits are in between 0 to 1 1. Sometimes they will give, sometimes they will not give, so you have to identify. Now the line integral, what is the line integral here? The line integral is integral f dot dr. That means integral f means here this is the f, and dr, that is the dx. So 3x square plus 6y minus 14yz j plus 20xz square k into our dr means here dxi plus dyj plus dzk, and after writing integral, so 3x square plus 6y into dx, directly we will write without calculation also, minus 14 yz into dy plus 20xz square into dz. So directly we will write this, we can write this step also. Now what is the x value, what is the y value, what is the z value? So x value, y value, z value is given. Now come to the first of all dz. So dz is equal, we'll get here, we'll get the 3t square into dt, and dy will get, so dy is equal to 2t into dt, and dx here will get the only dt. Now substitute all the results in this one because it is the parametric form. Now after substituting all, integral 0 to 1 3t square plus 6 into t is, what is the t? So y means here, y means t square and dt. So dx is nothing but dt. Next one minus 14, y is t square and z is t cube. dy is 2t into dt plus 20 into t square, z square, so t cube whole square, and dz 3t square into dt. Now integral 0 to 1, after rewriting, so it is the 3t square plus 6t square, that means it is the 9t square. The first part is 9t square minus it is the 14, here t square t cube into 2, so minus 14 into 2 means it is the 28, so 28 t square t cube t, that means t power 6 plus 20 into 3, it is the 60, t and t power 3 whole square, that means t power 6, it is the t power 9 will get, so t power 9 into dt, t power 9 into dt. Now just do the normal integration. Now the normal integration is t cube by 3 minus 28 t power 7 by 7 plus 60 into t power 10 by 10, limits from 0 to 1. Upper limit is 1, lower limit is 0. So directly we will write, after substituting upper limit 9 by 3, 28 by 7 and plus 60 by 10. For lower limit entirely 0. Now here we will get the 3 minus 4 plus 6. That means it is the 9 minus 4, you will get the 5. So 5 is the result. This is the line integral of the current problem. Next one we will see the second problem in this one. So line integral of vector fields. So line integral of the vectors field. So second problem, evaluate the line integral of vector f is x square I minus 2yj plus z square k over the straight line path from the points minus 1, 2, 3 to 2, 3, 5. Now, so here the previous one they have given the parametric form, that means the x and y values, but it is not given, it is the only function is given. Now you have to find the parametric form. Just find the parametric form. So here we can easily find the parametric form of this path, so straight line path. Anybody, how can you find the straight line path in parametric form?
Straight line equation.
straight line. What is the straight line equation? చెప్పాలండి, తెలిస్తే చెప్పండి, లేదంటే తెలియకపోతే తెలియని చెప్పండి, నో ప్రాబ్లం, విల్ ఫైండ్ ఎనీవే.
x minus x1 by x minus x2.
Very good. X minus x1 by x2 minus x1, very good. Y minus y1 by y2 minus y1, and z minus z1 by z2 minus z1, very good. Okay, now so assume it is the x1 y1 x2, this is the x2 y2 z2, then we will get the x minus of minus plus, so plus 1 by 2 plus 1, and y minus 2 by 3 minus 2, and z minus 3 by 5 minus 3 is equal, you have to assume the t, because we want to find the parametric form. Then what we will get here? Now x plus 1 by 3 and y minus 2 by 1 and z minus 3 by 2 is equal to t. After separating, here we will get what is the our x value. X is equal, we will get the 3t minus 1. What is the y value? Y is equal to t plus 2, and z is equal, what we will get? Z is equal 2t plus 3 only. This is the now parametric form. X is equal to 3t minus 1 and y is equal to t plus 2 and z is equal to 2t plus 3. Okay, now what is the our position vector? Our position vector is r is equal to xi plus yj plus zk. But now we can easily write now the what is our position vector now here? 3t minus 1 into I plus t plus 2j plus 2t plus 3 into k, and simply we can find the dx also. In place of dx you have to write the 3 dt, in place of dy you have to write the dt, and in place of dz you have to write the 2 dt. Okay, like that we can calculate. Okay, this is the one of the way, and we have the second way also. Is there any second way undandi edaina alternate approach? Suppose we have a interval like this, a to b. So this a to b we can write so this interval we can taking the 0 to 1. So 0 to 1 means now the straight line is, so straight line a of 1 minus t plus bt. After substituting, suppose t is equal to 0, we will get the a value. After substituting t is equal to 1, we will get the b value. That means here our r is our vector, we can write a plus b minus a into t. So from this formula also we can easily get the our parametric form. Now we will see. Now here I am using the formula r is equal, what is the first vector? What is the first vector? It is the first vector, and this is second vector. What is the first vector? So minus 1 comma 2 comma 3 plus b means here second point 2 comma 3 comma 5 minus 1 comma 2 comma 3 into t. But anyway we will write in the vector structure. So vector structure you can write r is equal minus I plus 2j plus 3k first vector plus what is second vector here? 2i plus 3j plus 5k minus of minus I plus 2j plus 3k into t. That means here we will get the minus I plus 2j plus 3k plus 3I plus j plus 2k into t. After rewriting what we will get here? Minus 1 plus 3t into I plus 2 plus t into j plus 3 plus 2t into k. Okay, anyway already this vector already we derived. So what is the r here? R is equal to 3t minus 1 into I plus t plus 2 into j plus 2t plus 3 into k. And in this one you have to take our t limits are 0 to 1 only. So here also you have to take the t limits are 0 to 1. So this is the second way. Okay. So this is the our x results, x, and this is the y, and this is the z. This is equal to x of t, and this is the y of t, and this is the z of t. Okay, that means you have the two options. You can calculate the our position vector by using the first formula or by using the second form. Okay, that is your choice. But anyway we have the two methods. Which one is best, first method or second one? See here, which one is the best, first one, second one? This is the first one, converting the parametric form. This is the second one. Which one is the best? Okay, speed. Okay, so that is choice is yours. My suggestion is better to take the second one. Second one is the best. Now we will evaluate our line integral. What is the line integral here? The line integral f dot dr. That means integral c is, what is our f? X square I minus 2yj plus z square k into dxi plus dyj plus dzk. Now substitute all the values. After substituting all the values, what is our limits? T limits are 0 to 1. What is our x? X gurtunda andi, 3t minus 1 whole square. Okay, I will write one more step here. Now integral c x square dx minus 2y dy plus z square dz into, okay, now substitute all the values. Integral 0 to 1 and x value. So what is x value? 3t minus 1. So 3t minus 1 whole, so x value, so x is equal to 3t minus 1. Y is equal, what is the y value? T plus 2, and z is equal to 2t plus 3, and dx is 3 dt, and dy is only dt, and dz is 2 dt. Just substitute these results. Now the first one is here, the 3t minus 1 whole square into 3 dt. Next one minus 2 into t plus 2 into dt. Third one z square, so 2t plus 3 whole square into 2 into dt. Now simplify. Now integral 0 to 1, after expansion here we will get the 3 into 9t square minus 6t plus 1 minus 2t plus 2, and here 2 of 4t square plus 12t plus 9 into dt. Now integral 0 to 1, it is 27 t square minus 18t plus 3 first part, and second one is minus 2t minus 4 plus 8t square plus 24t plus 18 into dt. After rewriting, now integral 0 to 1, so t square terms, now here the 27 here 8 means 35 t square, and the t terms, here the minus 18t and here the minus 2t and here the 24. After rewriting, what here here will get minus, so plus 4t only, and the constant terms, here the constant term here minus 3 and minus 4 and 18, here we will get the 17, so 17 plus 17 into dt is the result. Now after doing the normal integration, so t cube by 3 and 4t square by 2 plus 17 t limits 0 to 1, upper limit is 1, lower limit is 0, directly now we will write, so 35 by 3 and 4 by 2 plus 17 minus entirely 0. Now after doing the normal, so 35 by 3 plus 2 plus 17, that means 35 by 3 plus 19. What is the result? LCM is 3, so 3 35 plus 3 into 19. What is the 3 into 19 result? 3 into 19, 57 by 3. The total result is 92 by 3 is the result. Okay, so this is the result, line integral. So finally, in the line integral of the vector field, we have the two types. Sometimes they will give the directly parametric form, like the previous problem. The previous problem they have given directly, just you have to find the only t limits. But in the second problem, they have not given directly, they have given the 2 points. From the 2 points, first of all you have to generate the parametric form of the line equation. Okay, after that we can easily solve. So anyway, I am giving 3 problems in this line integral of the vector field. Now the first homework problem is evaluate the line integrals. Okay, so evaluate the line integrals. Evaluate the line integrals of following vector fields. The first question is f is equal to x y I plus y square j plus z e square k over the curve C, whose parametric representation is given by x is equal to t square and y is equal to 2t, z is equal to t, and t limits are 0 to 1. And sometimes they will give the this structure like this also. Sometimes x is equal to t square and y is equal to like this, x is equal to t square and y is equal to 2t and z is equal to t, and like this from the point 0 0 0 to 1 comma 2 comma 1. Okay, but luckily they have given directly t value in between 0 to 1. otherwise also you can easily identify. Okay, observe. Here already we have taken z is equal, so z is equal to t, so you have to take the z limits only. So this is the first problem, and second one is, now the second one is the find the total work done in the moving a particle in force field given by F is equal to Zi plus Zj plus Xk along the curve along the helix C is given by x is equal to cos t and y is equal to sin t, z is equal to t from t is 0 to, now here x is equal to cos t and y is equal to sin t and z is equal to, here t is the spherical form of this x, y, z. And the next third problem is, I will give the third one also, here the result. So result also I will give. So result is pi by 2 minus 1 is the result. Next one, third problem, in this third homework problem, problem number 3. Suppose a force field is given by F is equal to 2x minus y plus z into I plus x plus y minus z square into j plus 3x minus 2y plus 4z into k. The question is, find the work done in moving a particle once around a circle. See, in the xy plane with the center at origin and radius is 3. Okay, so anybody, can you guess what is the x, what is the y, what is the z in this one? Here x square plus y square is equal to 9 and xy plane. So xy plane means what is the z value? 0. So we have to assume like this. Am I clear? You get my point? Okay. Now here the what is the our x, what is the y, what is the z? X is equal, you can write the 3 cos t and y is equal to 3 sin t and z is likely 0. And what is the limits? So t limits are 0 to 2 pi. You have to take, because it is the total circular path. Okay. Now here I will give the results also. Results is 18 pi is the result. So 18 pi is the result. Okay. So this is the line integral of vector field. So it is the second type of problem. So what is the first type problem? Line integral with respect to arc length. Second one is the line integral of vector field. Now we have one more problem. So after this problem we'll stop. Okay. So this is the last one. I will take the more 10 minutes. After that I will stop. Okay. So the next one is, so third one. So here I am assuming f is function of x, y, z and g is function of x, y, z and h is also function of x, y, z. I am assuming are functions, scalar fields which are continuous functions, at the points over the C. Okay, that means here I am assuming the curve is, let I am assuming C be a smooth curve whose parametric representation or parametric form x is equal to function of t and y is equal to function of t and z is equal to function of t. So here from this one just I will generate a vector field. Now here the f is equal, I am writing fi plus gj plus hk, same as the previous one, same as the vector field. So this scalar field function I am converting the vector field. Now f is equal fi plus gj plus hk and now integral f dot dr, same as the previous one. Here integral c is equal to fi plus gj plus hk dot dr. What is our r here? R is the position vector, that is the xi plus yj plus zk, but dr means just differentiate, dxi plus dyj plus dzk. Now after substituting this dr, after substituting dr, what will get the result? So dxi plus dyj plus dzk. After doing the normal dot product of these two, integral c f dx plus g dy plus h dz. Observe, it is same like the previous one, nothing new. Okay, observe here also directly we will get. So these two are nothing new, both are almost all same. Here the line integral f dot dr is equal the line integral f1 dx plus f2 dy plus f3 dz. So this line integral of the vector field and the line integral of the scalar field, nothing new, it is almost all same only. Okay. Now what is our title? The title is line integral of scalar fields. Now we will see in this one problem, after that we will stop. Okay. Now the first question here, evaluate line integral 2x plus y into dx plus y square into dy plus x plus z into dz. And here we will solve the two problems. The first sub question is where c is x square is equal to y and z is equal to x and x values are in between 0 to t. And here this same problem they will give like this also. How? So same problem they will write in the line integral of vector field also. We can convert. How? Here they will give the f is equal 2x plus yi and y square j plus x plus zi into k, and curve is x square 2 is equal to y and z is equal to x, and x values are in between 0 to 1, and maybe the question is like this: find the line integral. So f dot dr, both are same meaning. Okay, anyway, now so it is clear. Now I am asking a question. Now where can you start the problem? By taking x value, by taking y value, or by taking z value? Observe in the previous one, the converting the parametric form, maybe in the first problem we are assuming just here. So here we have the two options: by x is equal to t we can solve, or y is equal to t. But in this problem, which one is the best? By taking x is equal to t, or by taking y is equal to t, or by taking z is equal to t? Where can you start the problem? చెప్తారండి ఎవరైనా? Hello? Okay, so in this curve, so if it is suppose linear, there is no problem, but in this one there is a non-linear term, so here there is a x square. So my suggestion is, first of all, just to focus on this x. So in this problem, so we have to start with the x variable. So in the parametric form, so x is equal, you will take the t, then what is the y value? So x square 2y, after substituting t square is equal to 2y, that means y is equal, here we will get the 1 by 2 t square, and z is equal to, anyway it is the t, and it is clearly given x is in between 0 to 2, so t value also 0 to 2. Now we have the total. Okay, now come to the normal integration. What is the normal integration? So normal integration. Okay, now we'll write first a function. Now the integral, so line integral 2x plus y into dx plus y square into dy plus x plus z into dz. Now substitute all the results. మ్యూట్లో పెట్టండి, కొందరు ఎవరో మ్యూట్లో పెట్టేసేయండి. వినపడుతుందా అండి? మిగతా వాళ్ళు అన్మ్యూట్ చేసేయండి వాళ్ళని, ఎవరినో. గోపీనాథ్, ఇంకా యాక్సెస్ ఉందా? సరస్వతి, జస్ట్ మినిట్. Okay, leave it. Okay, now integral 2x plus y into dx plus y square into dy plus x plus z into dz. Now substitute x, y and z. After substituting, now the limit 0 to 2 and x is t, so 2t, and y is 1 by 2 t square, and dx. What is the dx? So dx here dt, and dy. What is the dy here? After differentiating, we will get the t into dt only, because 2t will cancel, and dz is equal, we will get the only dt. Now substitute all. Now dt plus now y square. So y square means 1 by 2 y square whole 1 by 2 t square whole square into dy. So t into dt plus dz. dz is x. X is t and y. So z also t and dz is dt. Now simplify. Now integral 0 to 2 t plus 1 by 2 t square plus after simplification it is 1 by 4 and t power 5 plus 2t into dt. So integral 0 to 2, so 2t it is the 4t and 1 by 2 t square plus 1 by 4 t power 5 into dt. Now after doing the normal integration, what is the integration of this one is 4 into t square by 2, 1 by 2 into t cube by 3 plus 1 by 4 into t power 6 by 6. Correct Andy? Now the limits 0 to 2. Now to cancel it is 2t square first part and 1 by 6 into t cube plus 1 by 4 into 6 into t power 6. Limits 0 to 2. Upper limit is 2. So 2 into 2 square plus 1 by 6 into 2 cube plus 1 by 4 into 6 into 2 power 6 and lower limit entirely 0. So 0. Next one, after doing the normal simplification, it is the 8 and 4 by 3 I think. Next one, it is the 2 power 6. So 2 power 6 means here we will get the 2 power 2 to 4, 8 by, we'll get the 3. Correct and 8 by 3? Now 8 plus 12 by 3, so 4 plus 8 plus 4 will get the 12 is the final result. So this is the result. Okay. Anyway, this is for first path. Now same I will write the one more problem. So I am taking the second one where the path is. Second question here. Now I am taking the different path. Second path is, now C is y square is equal to 2x and z is equal to x and x limits are 0 to 2. Now where can you start the problem? In this one, in the first problem you have to assume x is equal to t. Okay. In the second problem, where can you start the problem? Y is equal to t. Very good. So y is equal to t. So in this one you have to take the y is equal to t. So y is equal to t, then this problem very simple. Okay. So compared to the first one I think very easy because directly they have given the x limits. X limits are 0 to 2. But in the second problem, x limits are 0 to 2 and here we have to assume the y is equal to t. That is the difference between the first path and second path. Okay. Anyway, we will solve the second problem. Okay, in the second problem, what is our curve? The curve is y square is equal to CR chappu. So y square is equal to 2x and z value x and x is in between 0 to 2. Now here I am taking y is equal to t. Then what is the x value? Y square is equal to 2x. that means t square 2. Now x is equal here 1 by 2 t square. Now next one, z value. So z is equal to already x, so z also 1 by 2 t square. Okay, that is okay. But what are the limits? 0 to 2, x value 0 to 2. But what we are getting? So t is 1 by 2 t square 2. So that means 0 after multiplying by 2, t square less than 4. That means what are the t limits? T limits are 0 to 2 only. Okay, so now we have to take the y is equal to t and x is equal to 1 by 2 t square, z is equal to 1 by 2 t square, and the t limits are 0 to t. Next one, now what is the dy? What is the dy? Okay, I will write again. So y is equal to t we are assuming, and x is equal to 1 by 2 t square, and z is equal to 1 by 2 t square. Now dy in place of dy you have to write dt, in place of dx you have to write t dt, in place of dz you have to write t dt only. Now come to the problem. So integral, what is the problem? So 2x plus y into dx plus y square into dy. Next time it's here, I think x plus y or y plus z. So x plus z into dz. So x plus z into dz. So x plus z into dz. Now substitute all parameters. Now the limits are 0 to 2. X is directly t square, because 2x is equal to t square. So 2x is equal to t square, and y is t only, dx t into dt plus, and y is equal to t, so t square into dt, and the next one is the z. Next one. Now x is 1 by 2 t square plus z is again 1 by 2 t square into dz. Now t into dt. Now after rewriting, integral 0 to 2 t square plus t cube plus t square. Now it is t cube plus t square plus, it is the t square plus, now this one is the 1 by 2, it is the only 1 by 2, it is 1 t cube only, into dt will get. Now it is the 2 times of integral 0 to 2 t cube plus t square into dt. Now after doing the normal integration, 2 into integration of t cube, t power 4 by 4 plus integration of t square is t cube by 3. Limits from 0 to 2. Upper limit is 2, so 2 power 4 by 4 and 2 power 3 by 3. Lower limit 0, that is entirely zeros. Now 2 I think here after simplification here it is the 16, 2 power 4 is the 16. Here we will get the only 4 plus it is the 8 by 3. Now in this one I am separating 4. Now 4, 1 plus 2 by 3, So 2 into 4 into 5 by 3, it is 20. 40 by 3 is our result. Okay, so this is the question. Now here I am giving the homework problem. The first one, just to try to practice the problem. Now evaluate the line integral x plus y into dx minus x square dy plus y plus z into dz where the curve is C is x square plus 4y and z is equal to x and x values are in between 0 to 2. Okay, so ఈ ప్రాబ్లంలో ఏది ఫిక్స్ చేయాలంటే x, y, z and what are the limits of the t also చెప్తారండి ఎవరైనా? x is equal to t is the best. ఓకేనా అండి? అయ్యో
ఓకే సార్.
అయ్యో ఆకలిస్తుందా అండి? ఓకే, సో ఇదే లాస్ట్ అండి, ఆపేస్తాను. జస్ట్ 1 minute. నెక్స్ట్ వన్ మోర్ ప్రాబ్లం. Now y square is equal, I am taking 4x and z is equal to x. X values are in between 0 to 4. ఇందులోనండి what are the t limits and where can you start the problem? Okay, so I will give the hint. Okay, no, okay, I will not give the hint, just do the problems. Okay, so the first result is answer 10 by 3. So second problem it try check. Okay, so anyway I will stop now. So thank you to all.